I want to welcome you to Duo System Hot Standby lecture. And like many of you have told me, Duo means something like two hot. You told me like a machine that is powered on and running. Standby, you told me something waiting in standby mode. It is actively waiting to take over the role of something, and we're going to be able to understand what some of those things mean in detail, and we're also going to be able to understand why is it important for us to have a dual system hot standby. Initially, like I explained to you before, we have our firewall, right, which is put at the egress or the entrance of our network. We have our to be protected network, our intranet, and we also have the external network, which we are protecting our our intranet from. It could be the internet, it could be other networks which could have hackers or intruders or people who would maliciously want to attack our network and be in position to distort our normal functioning of our network. So we have our firewall put in between there to help us. What did we say the firewall does? The firewall helps us to protect our network, right? By filtering our traffic or data flows that are going in through and that are going out of our internet. But remember, still, our users here, our authorized users on our internal network are going through the firewall to access the internet, right? They're going through the firewall to access the internet because they need to access the internet for some resources. One, maybe to send emails, maybe to read emails, maybe also to get some resources from our different clients, etc. Now, a scenario comes for one reason or another, maybe a rat goes into our network rack and they bite our cable, right? We have a rat here. It goes, I don't know how to draw a rat, but it goes into our network system and it bites our cable. Or maybe there's some kind of power failure. All our firewall just, for some reason or another, fails at that given point. And there's this client here, our user inside our network, client A, who wants to urgently send out an email, let's say a contract or a bid, and the deadline is maybe has reached today, and we really need as an organization to be able to place in that tender. Do you think our client A here, when our firewall is off for one reason or another, will be able to access external networks or to access the internet, or maybe even to send and receive mails, much as yes, our ISP, internet service provider, the link is on, it is up and running. But remember, all our traffic, in order to protect our network, is going through our firewall, which at this particular point is off. Quick question here. Do you think our client A here will be in position to communicate with external, external networks? Quick question.
Yeah,
No,
yes,
so they won't.
yes,
Really.
Yes, please.
But you won't be protected from the outside the internet.
They won't be protected from the outside internet. Anyone else? Thank
They
you.
will not be able to communicate due to the fact that all the traffic is being driven through the firewall, and so the firewall is acting as the default gateway. So at that point, the default gateway or the bridge is broken, so there will be no communication unless there is a fallback other connection.
Hello.
Perfectly said. Well said. They will be unable to they will be unable to communicate, to send through our packets, because remember, we can connect our firewall in mode 1. In this case, it's going to act as a bridge, or even in mode 2, where we are even going to modify our our topology, and we're going to configure gateways on our firewalls, isn't it, to enable our users to be able, which works here at layer 3, to be able to communicate and send packets and receive packets. But now it is off. How will it be able to manage and send out those packets and receive those packets? It is off. So our user here will not be able to communicate unless, like what Romeo said, unless when there is a fallback or backup plan in case this firewall is off. We have another firewall that is up and running. We have another device on our network that is up and running in standby mode. It is hot, it is on, up and running, and it is ready to assume duties in case the master is not available. So this is what we want to look at today, and want to look at a dual system hot standby. Moving forward with the rapid development of services such as mobile office, people working from home, online shopping, people buying things here and there, instant messaging, people sending messages in group, which Mr. Wine is not happy with, internet finance and internet education, network scarring, increasing services, and therefore they have become very important. We rely on networks today to carry out almost all transactions, have meetings, do transactions online, buy things online, change, give orders, directives, everything over the networks. So how to ensure uninterrupted network transmission is an issue that needs to be solved urgently during network development. Like you as a network engineer, even when you are choosing to come up with when you're choosing to come up with your network architecture, you need to make sure as you're putting it all together, you have put in mind that you don't want your network to be interrupted. And should it be interrupted, you have also put up mechanisms to make sure that they will mitigate a single point of failure. So dual system hot standby improves reliability, that our network is going to be reliable. So here we can use two firewalls, or two firewalls can be deployed at the egress of a network to ensure that communications between the internet, between the intranet and the internet are up and running. It ensures that there's communication, that there is reliability, and this is what we are looking at today. So upon completion of this chapter of this course, you'll be able to master the technique principles of dual system hot standby, and also master the basic configuration of a dual system hot standby. So let us look at the technical principles of the dual system hot standby. So why dual system hot standby? Why should we use dual system standby? We have our security device here, right? And we are saying a security device is usually located at the service connection point. We are connecting our intranet with our intranet. And it's between our to be protected network. Here on our intranet, it's our to be protected network and our unprotected network, which is the internet or the other external kind of networks. So if only one device is used and deployed at this service level, it's only one device, you have your firewall A. If it is only one device that is used and it's deployed at the service connection point, network services may be interrupted due to a single point of failure, no matter how reliable the device is. To prevent network service interruptions due to a single point of failure, we can deploy two firewalls to form a dual system hot standby. So like you are seeing, this following figure shows a traditional networking mode. Packets exchange between intranet and intranet users, and they are transmitted through firewall A, this firewall A here. So a firewall is a fault. If firewall A is faulty, intranet hosts that use firewall A as a default gateway cannot communicate with the internet, thus affecting connection reliability. So these guys which are using this as a gateway, they're using this as a default gateway to be able to access the internet. Once they send their packets and the gateway cannot be reached, then that means that our PC here, our client A, will not be able to communicate due to a single point in failure. And to avoid that, we said we can use two firewalls to come up with what we're calling a dual system hot standby. So let us look at the redundancy deployment solutions for routers. What comes to your mind again? I'll ask when you hear the word redundancy.
I check.
Go ahead, Romeo.
It is the reliability of, let's say, a system or a network. In case of anything, it has another plan, or at least its strength of reliability is, its ability to be relied on is a bit higher.
Okay.
Hello.
Thank
Hello.
you. Yes, please.
Redundancy may refer to having substitute
Having.
a substitute system ready to go.
Very good. Thank you.
Mic check.
Yes, Brian, go ahead.
I think redundancy means, let's say, failure to have what to do. Like it's redundant. It's not doing anything at that moment.
Okay, failure to have what to do. Okay. Thank you all for sharing. So here I want to look at the redundancy deployment solutions for router. Usually, previously or traditionally, a common solution to a single point of failure in a standard router networking is to set up a protection mechanism based on the failover between links using a dynamic routing protocol, where you can either have ALCP, the link aggregation control protocol, whether you can have Ethernet trunk and bound many links together into a logical link, and one of them is acting as a redundancy of the other. However, this protection mechanism has limitations. If the protocol or the routing protocol itself is unavailable, that means that services may be interrupted due to a link fault. And to address this problem, another protection mechanism, which people call the Vrrp, or what we are calling the virtual router redundancy protocol, is used for router redundancy. It was introduced and it is a basic fault tolerant protocol. It brings over a short failover. It doesn't guarantee that your network will not fail over, but at least the distance between you switching, or the time between switching from one router to another, is shorter. So it brings a shorter failover duration compared with the broadcast packets that depend on dynamic routing protocols, and also provides link protection even if no dynamic routing protocol is available. So here we have our Vrp group. We have our Vrp group where we have a master router, where we have a master router, and we also have our backup routers within our Vrp group. So a Vrp group usually is a group of routers in the same network broadcast domain, and they form what we are calling a virtual router. So all these guys in our Vrp group form what we are calling a virtual router. So it's more like a virtual router, but this virtual router has a group of routers that are put together, and these routers, most importantly, are all working within the same broadcast domain, so that they're able to send routers. So all the routers in this virtual group provide what we are calling a virtual. If I hide the video panel, okay. Yes, I'm saying that all the routers in the group provide a virtual IP address as the gateway address for the internet. So we have our group, we have our routers inside, and it forms one virtual router. This virtual router gives us a virtual IP address, and we said we are using this virtual IP address as our default gateway on the network. So they're using, all these routers are using one default virtual IP address as our default gateway or address for the intranet. So we have a master router.
Mic check.
Yes, Romeo?
So does it mean that all these routers will be configured with different IP addresses, and at the end, if you want to connect to the intranet, as you're giving the default IP, as you're giving the default gateway, you give them one, you merge all those IP address, or you convert them into one IP address and you give them one IP address, or when you're configuring, you give like 3 different IP addresses. Say in this case, we are having 3 routers.
Yes, you configure them and you give them, of course, different IP addresses. But these different IP addresses are, like in this example you're seeing, are on the network of .10, right? They are within the same network domain. And we are going to use this protocol to configure a virtual router redundancy kind of protocol. And after we are doing that, we are going to formulate a virtual router. And there are ways you give this virtual router a virtual IP address, which also is within the same network range with our routers inside here. So using this protocol, we come up with a virtual router, and this virtual router, you go ahead and assign it with one IP address. Now, the people connecting to these protocols, for them, they are not aware of this particular time. Yes, okay, we're using the master backup, but they are connecting to this group using our virtual IP address. And later on, you're going to appreciate why that is important. In case even the master is off, we don't have to go back on all computers on our network or go on our DHCP and change our default gateway, right? And say, oh, this default gateway, which we had configured earlier on of 10.2 is now off. So now I need to change and configure and now put it in, and it's now .3, right? For them to be able to access. No, this particular case, you just configure one default gateway, which is also a virtual kind of IP address. And if this guy is off, this guy will assume the master role, like we are going to explain later on. And after assuming the master role, he's the one who is forwarding and receiving packets in actual sense, in reality, physically speaking. But these guys on our intranet are connecting to this guy through the virtual IP address. And we don't have to come back in our network topology or architecture and configure and change our topology. So this is a master backup. We are saying that in a group, we have a master router. And the role of a master router, it is among the routers within the same virtual group, Vrrp group, and only one router is active as master. We can only have one master at a time, and only the master can forward packets with a virtual IP address as the next hop. So they just forward, the master is the one that is doing on the routing job. In the meantime, as these backup routers are, sleeping and they are waiting in standby mode. They're up and running, but they're waiting in standby mode to go ahead and take on the responsibility of a master router. So we have our backup, we have our backup routers, and our backup routers here, basically, they are unlike our master router. All routers in the Vrrp group are on standby. They're backup. The master router periodically sends hello packet to the backup routers in multicast mode, because you have configured a group and they know. Multicast, it means to all the many known hosts. So it sends them in multicast mode, and the backup routers determine the status of the master router based on the hello packet. So if this guy receives the hello packet, they will know, oh, our master router is still up and running, and okay, we can wait. We shouldn't really, take over his position. He's still the president. He's still in charge. He's still, doing his duties as we have, as he's supposed to do. So because the Vrrp hello packets are in multicast packets mode here, and we are broadcasting to many, the routers in the Vrrp group must be interconnected through layer 2 devices, because we don't have to do any kind of network any kind of layer 3 routing, same network broadcast domain. So we must connect these guys using switches or layer 2 devices. So when Vrrp is enabled, when you go ahead and enable Vrrp on our routers, the upstream and the downstream devices must have the layer 2 switching functionalities. So otherwise, the backup routers cannot receive the hello packet sent from the master. And if the network requirement is not met, then we shouldn't use Vrrp group. So our routers must support layer 2 functionalities, and also the devices we're going to use must also support layer 2 layer 2 functionalities. So this is what we are calling virtual router redundancy protocol, where you can put routers in a virtual group, and your virtual group has a master router which is doing all the forwarding of packets, and we have our backup routers in standby mode, and all these guys form what you're calling a group, and this group is also looked at as one virtual router with one or with a virtual IP address. So let us look at the application or Vrrp group.
Mic check.
In a multi-zone firewall networking. Yes, please.
Mr. Sandy, though, back to the previous slide. I mean, how are they ranked? If the master router is down, how are the two routers ranked? How do they know? Do they have some sort of internal ranking that they know that I'm ranked 1 or 2, and then if the router is picked up, it's router B to follow suit to take over as the master? How are the two routers ranked? Thank you.
That entirely depends on your configurations and the priorities. You can configure that and you can give them the priorities. But since this is not a networking course, we are not going to focus so much. We want to focus on the dual system hot standby. And we are also going to be able to see how they are able to rank. But using the hello package, they can determine the state of the master and to know if the master is on or off. And then in case the master is off, then depending on your configurations or the priority levels, then the backup router will be in position to take over, and then they will assume the duties and role of a master. And even in case the master comes back up, there's also what you can configure and either determine whether the backup keeps on being the master or the master will now assume back the role of a master, and these other guys go back into backup state. There's a datacom class that is going to be taking place, which will be explaining more of those networking concepts in detail. So kindly, when you see the ad, just register if you want to be able to dig deep into these guys and understand how is the process of, configuring the master, of electing the master, how is it done to detail, and then you'll be in position to answer all those questions accordingly. So we're looking at its application in firewall networking. So to provide dual system hot standby for multi-zones on firewalls, you must configure multiple Vrrp groups. If you want to be able to access or to apply this kind of analogy or system in our multi-zone firewalls, you need to be in position to configure multi Vrrp groups. So if multiple zones on our firewall require the hot standby function, you must configure the multi Vrrp group on each firewall. And a firewall, usually firewalls are stateful firewalls, and they require the forward and reverse packets to pass through the same firewall. To meet this requirement, the status of all Vrrp groups on a firewall must be the same. That is all Vrrp groups on the master firewall must be the same as that of the master, so that all the packets can pass through the firewall and other firewall functions as the backup firewalls. Now remember, we have multi-zones on our firewalls, and if you have multi-zones, then means we must come up with different groups. We create virtual group 1, for example, we create virtual groups 2, but we are saying that most of the next generation firewalls are all working in stateful mode. Who remembers we talked about stateful inspection? What did we say it does? Anyone?
Inspect the type of protocol being used by traffic.
Okay.
Mic check.
Go
Mic
ahead,
check.
Brian. Go ahead.
In a stateful mode, the firewall uses bases on the first packet sent to establish connection with the server. I mean, if the first packet is configured, if the first packet allows establishment, then all the other packets just go through without the firewall having to check them again.
Thank you, Brian. So yes, we said with a stateful inspection, what it's going to do, they're going to first inspect, they're going to first process the first packet. And if the first packet it matches the rules on our firewall, it's going to go ahead and update the session table and say, oh, these guys that belong to this session, okay, they are allowed maybe to go in through the server, and then it gives us faster processing of the subsequent packets. So the subsequent packets that are going to be going in and out of the firewall, they're not going to be processed, but they'll just be processed as subsequent packets, giving us a faster kind of processing and also giving us better efficiency. That is a stateful inspection. Inspect and process the first packet and check other packets. Just check their sessions and see if they belong to the same sessions. Go ahead and do the subsequent kind of processing. But we say this now requires for these guys, because if the session tables, for example, are updated on this firewall, our master firewall, and for some reason our master firewall goes off, now the backup firewall does not have this session, right? And it doesn't know about what you're talking about. And now, because we have our kind of redundancy, we know if master is off, backup, assume and take responsibility. Now the subsequent packets are coming back through, or even the kilo packets coming through the subsequent packets now are being sent. This guy is going to receive the packets. He's going to check his session tables. And he's going to be like, I am unaware of this. I do not have any session. And it may even go ahead and do processing again, or even go ahead and discard the packets because it is unaware. To solve that kind of problem, we are saying that all the master Vrp group must be in the same state as the backup group. Whatever is happening here, whatever sessions have been updated, we also need to come up with a mechanism to make sure also the backup is updated with whatever is transpiring here. In the event that this guy is off, still this backup has all the instructions and details about what has been transpiring on our network. Previously, we talked about the different zones, right, on a firewall. We said we have the trust zone, and we said the trust zone is usually the to be protected network. The trust zone, the computers behind the to be protected network, and they usually even don't need to first go through the firewall. They are computers within the same trust zone. They trust each other. Yeah, we have those. We have that trust zone. We say the default zones on the firewall. Can we modify them, or we can't modify them or change them?
They can be modified.
They can't be modified. That's what we said, yes. So we have our trust zone, and it has, I think, priority number 8. We also have our demilitarized zone. Usually it is used in the data centers, etc. It has the trust zone of about 50, and these ones cannot be changed. And we have our untrust zone, the network we are protecting ourselves from, and that is zone number 5. And we also have another zone which is inside the firewall, which we are calling local, and for it has the highest. It has about 100. So this is the Vrp group. Everything that is transparent here must be everything that is on the slave for us to make sure that our subsequent packets are not discarded if these firewalls are working or are operating in stateful inspection mode. And we said most of the next generation firewalls today are using the stateful inspection mechanism. Okay, so moving forward, we have detect over Vrrp in firewall application. So in traditional Vrrp mode, the status of the master firewall cannot be consistent with that of the backup. We said for the subsequent packets to be easily processed, they must be the same with the backup, right? But we are saying that in the traditional Vrrp mode, the status of the master firewall cannot be consistent with that of the backup firewall. And why? Just like you see in this figure here, assume that our Vrp status of our firewall A here, is the same as that of firewall B. Therefore, all the interfaces of firewall A are in the master state, and the interfaces of firewall B are in the backup state. So PC1 here is in the trust zone and accesses PC2. And PC2 is in which zone? The untrust zone, the network we are protecting ourselves from. Okay, so it accesses PC2 in the untrust zone. So the packet forwarding paths, like you can see 1, 2, 3, and 4 to firewall. It is our path which we are going to use to forward the packets. And firewall A here is going to forward the access packets and dynamically generate sessions in our entry table. We have our session entries, which are, updated. So when the reverse packets from PC reaches firewall A through 4 to 3, and it is coming back, right? It's accessing our network. It matches the session entry and therefore reaches PC1 through 2 and 1. The session entry, when the packet is coming back, but first of all, is going to check its session entries. Oh, there's a session that I updated about this. These guys are all in the company van. We should let them go out. We let them come in last time, and they're also allowed now to move out. So it goes ahead and does the subsequent kind of processing. It matches the session entry, and it will just go and reaches. And also, similarly, PC2 and the server in DSM can communicate with each other. Even this guy, same session. This guy is going to go ahead from PC2 5, 6, 7, 8, send packet to the server in DMZ, demilitarized zone. And this server maybe to access some packets on our file server, checks and see the session entries have been generated here. As a packet is coming back 7, 6, it's going to check our session entries. Oh, yeah, there's a packet, first packet, it was, processed and everything is cool. I've shown the ID, go ahead and process it and sends it through. So now, assuming that the Vrrp status of firewall, the Vrrp status of firewall A here, assuming that it is different of that of firewall B, right? If the interface connecting firewall B to the trust zone is a backup state, but the interface in the trust zone is in the master state, and PC1 sends packets to PC2 through firewall A, right? It's going to go ahead and send packets through firewall A. Firewall A will go ahead and dynamically update its session entries, just like normally. So the reverse packets from PC2 now return through 4, 9, okay? And you see 9 now here is pointing at firewall B. So firewall B does not have any session entry of this data flow, and there's no packet filtering rule on firewall B to allow the packet to pass through. What firewall B will do will be like, okay, I don't have any sessions, and my default action, what is the default action for firewalls most of the times? Otherwise, it's to deny. Okay, so it will go ahead and discard the packets. As a result, some guy here who was trying to access his files, he will be denied permission to go ahead and access the resources he wanted to access, and therefore we have an interruptions on our network, which is not really nice. So the cause of the problem is that the packet forwarding mechanisms are different. For router, each packet is forwarded based on the routing table. It will just take its routing table. If after the links, switch over, subsequent packets can even still be forwarded. As long as those entries are in the routing table, for it doesn't matter. Once it comes back on, it will just take the routing table and then forward after everything has been put up online. Now for firewall, since they work in stateful kind of mechanism, remember the first packet is allowed through, the firewall creates a quintuple session connection accordingly. It's going to go ahead and update these details with a quintuple selections. We said quintuple has how many things?
4.
There are 5. Having our source, IP address,
destination IP address,
destination IP address,
source port,
Destination port.
protocol.
and the protocol used. So firewall A here, working in a stateful inspection, it's going to go ahead and update these things. What is this guy's IP address? This guy who is trying to send things to the server, his IP address, let's say, is 192.168.1.2. And what is this guy's destination IP address? Maybe it is 10.10.1.1. And after that, it's going to say, what is the source port we are using? We are connecting to it maybe through telnet. Port 23. What is the destination port? Still port 23. What is the protocol we are using? Where maybe we are connecting either through still telnet, or maybe the application we are using. What is the port? Or maybe we are using through the web and they're connecting through port 80. It's going to go and update the sessions and put them there. Very good. Now, subsequent packets, including the reverse packets matching this session, can pass through the firewall if everything in the session is there. Once the subsequent packets come, it will check and see, oh, that we have the packets. Yes, well and good. Let them go through. Now, what will happen? This guy does not have the packets, right? And it wants to send and process the packets, right? It will not be. So if there is a link fail over and this guy goes off, maybe the rat comes and bites this cable. And we only have to access our firewall, our server using our backup. This cable goes off, or maybe power in this rack goes off. Someone accidentally switches off, turns off the switch, and it is off. And this guy is now the one, oh, I've been waiting for a very long time. I am now the master. Should you want to communicate on this network, I am the guy to talk to. Kindly go ahead and talk to me. Now, if there is a link switch over, subsequent packets cannot match the session entries on this firewall. They cannot match the session entry, thus resulting in a service interruption. So there is a problem. Similarly, the same applies even if we are using routers. We said for them they use routing table. But even if we're using routers, and we are using NAT. Remember, NAT translates the address, and the router goes off which has translated that address. Then we can also have a problem occurring after a new entry is created after NAT. So that is what happens when we are using stateful inspection on a firewall. Could you please mute your microphone? Please, kindly. So use of Vrrp for firewall multi-zone backup. To ensure that switchover consistency of all Vrrp groups, the Vrrp group management protocol is developed based on Vrrp. We said Vrrp matches, yes, it is helping us to create redundancy, but we have a challenge with stateful inspection firewalls. For them, they're going to process the first packet and then perform the subsequent processing of the subsequent packets. But in case the sessions are not the same and they're inconsistent, then our packets are going to be discarded, thus defeating the purpose why we are coming up with a dual system, hot standby kind of system. So to solve that problem, the guys were like, you know what? I think we can come up with some kind of protocol that is going to help us manage our group. So they decided to come up with a Hrp group management protocol, the VGMP, and it is also developed based on the way Vrrp group. So what is this? The requirement for the application of Vrrp group on the firewall as follows. One, we need to make sure we have consistency of our Vrrp groups. There's consistency. And then the session table status backup, because now the problem is coming with the session tables. What should we do? Let us use this protocol to make sure that we back up our sessions as well, to make sure that they reflect what is on our master is also what is on our backup. So multi Vrrp groups on a firewall. We have group 1, we have group 2. On a firewall can be added to one VGMP group. These guys are created, they are put together, and they are added to one VGMP group. Here, we have multi of them. VGRP1, VGRP3, these guys are, bounded together and put onto one VGMP group, which manages the Vrrp groups in a unified manner. For it, its role, like you hear the word management, it is to manage. So VGMP controls the status switchover of Vrrp groups in a unified manner, ensuring that there's consistency status of the Vrrp group. This guy is now going to come in as a regulator. He's like, okay, I know your group. You can have multi-group, and this group could be having one or two or even more, kind of firewalls or routers within it. But its role, they are, put together, and we come up with our VGMP groups. So if you have a VGMP group, its role is to make sure it manages this Vrrp group in a unified manner. It knows which has been, updated, which has not been updated. It also knows the status of this kind of, firewall. It knows the status of the sessions. So it will go ahead and say, okay, this guy is off. Now, basing on what I know, I think this guy, B, is the one who is most suitable on taking up the role of being the designated survivor. So the basic principle of VGMP group: if the VGMP group on the firewall is in the active state, then all groups in that VGMP group are in the active state. And the same applies to the standby, applies with standby. So if all the VGMP status is standby, then all these groups that are attached to VGMP standby are also in standby kind of mode. And the firewall in the VGMP active state regularly tests the peers running status, including the priority and also the Vrrp member status, by sending hello packets. How do you determine who is the master or who is the slave, or even the master is on? They are using the hello packets to go ahead and determine and see that this guy is up and this guy is not up, or this guy is down. So you can specify the VMP group status to determine the active or standby firewall. And if the group in the firewall, like we have said, the VGMP group on the firewall is in the active state, then all Vrrp groups in the VGMP group are in the active state. So this firewall is the active firewall, and all packets are going to be passing through now this kind of firewall. So in case the VMP group on the other firewall is in standby mode, then the firewall is also here. This firewall here now will also be in standby, will be in standby kind of state. And the firewall will also be a standby firewall. So each firewall has an initial VGMP group priority. And if our interface or a board of the firewall is faulty, like let's say its interface goes off, or even the motherboard is kind of faulty, maybe keeps coming on and all not, then the priority on the firewall starts decreasing, right? It starts decreasing. That way, this guy will only base on the firewalls with the highest priority, because they have been more consistent, and to give them the highest priority noise. As long as this guy is on, he's the master. Why? Because his priority values are higher. He has not gone off in a very long time, and he has been on consistently for quite some number of times. So he is our master kind of firewall. So the initial VGMP group priority on Huawei firewalls and the next generation firewall module is usually 45,000. Usually the initial group. And the initial group priority on the next generation on these firewalls depends on the number of cards all in the line processing LPU and the number of CPUs on the service processing unit. So we are saying that similar to Vrrp group, the VGMP active firewall regularly sends hello packets here. These hello packets send the hello packets. Hey, hello, are you there? Oh, I acknowledge, I am up and running. So it always sends hello packets to the standby firewall to inform this firewall of its running status, including the priority and the status of the member Vrrp groups. The member status is dynamically adjusted so that the two firewalls can perform active standby switchovers. So this guy is going to keep on saying, hello, I'm the master. I am your master. Please listen to me. This is my status. This is my priority because I've been consistent. My priority value is, let's say, this. And now I have these members within my state. And also These are the details that concern me. So kindly note that I am still in charge, not take on or assume my positions. But in case the status, the priority, the status are not better than this, then this guy will be like, oh, so meaning all along, for some reason, you have been inconsistent and I actually can perform better than you. So the Gmp group will now, conduct the switchover because this guy has now a better priority and this guy will become the master. Or in case the hello packets cannot be sent within that default time from this guy, then this guy will be like, oh, okay, the master is off, so I assume to be the master at this current time. So the difference from Vrrp group, or the difference is that the VGMP standby firewall receives a hello packet. After receiving the hello packet, it replies with an acknowledgement message carrying its own priority and status of member groups. By default, we said that VGMP hello packets are sent every second. Packets are going. And if the standby firewall does not receive any hello packets in that given second from the active firewall after 3 hello packets periods, that is after 3 seconds, because one happens after 1 second. So after 3 seconds, if this guy does not receive a hello packet, then the standby firewall regards that the peer fails and then switches over to active state. This guy after 1 second sending hello packet, hello, I am the boss. Hello, I am the boss. Hello, I am the boss. I acknowledge you're the boss. In case this guy does not receive in the first second, what is happening to the master? Is he okay? Maybe for network issues or whatever the case may be. The next second, and the third second, then this guy will be like, you know what? I cannot hear from the master. I think I am now going to self-declare myself to be the master, to take on the responsibility. So management of a VGMP group, like we said, we need to have consistency management. The VGMP group controls the switch over of all Vrrp group. This protocol here, the Vrrp group management protocol, controls the switch over. Which one should be active, which one should be standby. This is done by this guy. So whenever the status of the Vrrp group changes, this VGMP protocol must be notified of the change. And the VGMP group determines whether to allow the master backup switchover of the Vrrp groups based on some of the things. And if the status or switch over is necessary, then the group will go ahead, the protocol will go ahead and instruct all the groups to perform the switch over. You know what? I have assessed your requests, I have seen, and now I go ahead and permit you to go and do the switchover, become the master, and the other guy becomes a standby. Therefore, after an active Vrrp group is added to a VGMP group, its status cannot be switched separately from the group. Preemption management. In case the master comes back on, what should we do? In case it comes back on, what should we do? So if the faulty device recovers, so does the priority of the device. In this case, the device can become active again through preemption. It's going to preempt the VGMP group, and then the VGMP group will determine that, okay, your status is better. You are off, we acknowledge, but you can do a better job because maybe you have more processing, power, maybe you have more, cards. So go ahead and take on the responsibility, and then it will perform. It will give them the option to allow them to do the switch over. So basic concepts of Hrp. Huawei Redundancy Protocol, what we are calling the Hrp, backs up dynamic status data and key configuration commands between firewalls. So Huawei came up with this protocol to help to make sure that dynamic status data, our sessions, right, and our key configuration commands between the firewall are backed up across the firewalls within the different Vrrp group or the VGMP groups. So in hot standby networking, if a fault occurs on a firewall, all packets are switched to standby firewall, and the firewall are stateful in nature, and in a standby firewall does not have the connection status data. Like we said, the subsequent packets will not be permitted to go through, and therefore we shall have interruption in our connection. And to restore the services, the user must initiate or reinitiate the connection, which is not really good. So Huawei came up with the Hrp, or the the Huawei Redundancy Protocol, and this module provides a basic data backup mechanism and transmission function. Each application module collects the data that needs to be backed up by the module and submits the data to the Hrp module. And the Hrp module then sends the data to the corresponding module of the peer firewall. And the module passes the data submitted by Hrp module and then adds it to the dynamic routing data pool of the firewall. So we have different modes which we can use to make sure that we go ahead and back up this data. So it's going to make sure it consistently updates the configuration commands, and also to make sure that it updates not only the configuration command, but also the dynamic status of our firewall. We can, the kind of data we back up, session tables, server map entries. We also back up dynamic blacklisted entries, no part entries, and Hrp entries. The direction, usually the firewall with the active VGMP group backs up the required data to the peer. If this guy is the one in active mode, he's the one backing up to the peer. That is the direction. The channel, the ports that are directly interconnect the two firewalls are used as the backup channel. These ports now, this is the backup channel. They are used as the backup channel, which is also called the heartbeat link. The VGMP uses this channel for communication. This is our channel, what we are calling the heartbeat link. So the heartbeat interfaces, usually backup accounts for about 20 to 30% of the service traffic, and you can determine the number of Ethernet track interfaces that you can, put together to enable effective backup of data. So the two firewall exchange backup data through heartbeat interfaces over the heartbeat link. And the heartbeat interface must be independent interface with an IP address, and it can be physical interface such as a gigabit Ethernet interface, or it can also be a logical Ethernet trunk that you have bounded together. So it can either be a logical or it can be a physical, like gigabit Ethernet, that is going to be able to send the packets, or it can be a bundle of many physical links that form a logical kind of link for maybe link aggregation or for redundancy. So they can be those two. About the status of heartbeat interface, the heartbeat interface has 5 states. It has invalid, it has down, it has peer down, it has ready, it has running. Now, for invalid, here, the first one, for invalid, the physical status is up. The link is up. Like we can see, this PC is turned on, the other PC is turned on, the link is up, but the protocol is down. The protocol is not configured for one reason or another, and the network and the local heartbeat interface is incorrectly configured. Okay, like we have this guy, the physical links are up, but when this guy tries to, to send package to this guy, there's no protocol configured on this interface, and therefore that's why it is called invalid. Now let us look at peer down. With peer down, this means that the physical and protocol statuses are both up, like we have acknowledged that they are both up and running, and the local interface or heartbeat cannot receive the heartbeat link detection reply packets from the peer heartbeats. And in this case, the firewall sets the status on the local heartbeat interface to peer down. So if my status is up and running, and I am able to send out those heartbeat packets, so the status is up, and also the protocol is up, but I do not receive, and I do not receive replies from this guy. I don't receive replies from that guy. Then my link here, or the state, will be peer down. It will be in a state called peer down. And then there is another one called down. Now down here means both the physical and protocol statuses of the local heartbeat interface are both down. Okay, so here down, the link is not up, turned up, everything is off, the physical and the protocol, they're both down, so it will be down. We have running, or we have ready. Ready, the physical protocol here, the physical protocol and the physical and protocol statuses are both up and running, and the local heartbeat interface receives the heartbeat link detection reply packets from the peer heartbeat interface. This guy can be able to receive the reply. This guy can be able to receive the interface. That's why it's called ready. They're in a ready state to send and receive heartbeat packets, and it can continue sending packets to the heartbeat link detection packets to keep the heartbeat status up and running. That's why it's called ready. When it comes to running here, when multiple local heartbeat interfaces are in a ready state, when you have multiple running, that's when we be in a state of running. And the firewall sets a status to the first configured one to running. And if one, let me first finish, and if one interface is the ready state, then the firewall sets the status of running, of the running, statuses to running. Basically, this one, it has multiple, and they have been configured, and the first one is called running, the one which is going to be able to send the packets to come in and come out. Other local heartbeat interfaces are in a ready state, and they serve as backup, and they're ready to take up services in case there's going to be a switchover, or when the running heartbeat interface on the network on the heartbeat link fails. In summary, the heartbeat link detection packets are used to detect whether the peer heartbeat interface can receive the packets and determine whether the heartbeat link is available. That's the purpose of these, bits. And the local heartbeat interface sends heartbeat link detection packets as long as its physical and protocol statuses are up. And we say these protocols or these packets are sent every after a second. And as previously discussed, these packets are used to detect whether the peer device in that group is working properly. And basically, that is it. Yes, someone was saying mic check.
Good morning, and thanks for the opportunity. I had the
You muted yourself, so I didn't get what you're saying. Okay, so we said this protocol, the Hrp, is going to help us back up our status or the different session and the different configuration commands. Now we want to be in position to try and understand what are some of the different ways we can actually back up that information, and what we back up in those different modes. And there's one, automatic backup. You know what automatic means? By default, the automatic backup is enabled with the firewall to automatically backup configuration commands in real time and the status information regularly. This backup method applies to various hot standby network. And after this backup is enabled, every time you execute a command that can be backed up on the firewall, then the command immediately backs up the data on other firewalls within your group. And after automatic backup is also enabled, the device then periodically backs up the status information that can be backed up on standby devices. Therefore, the status information of active device is not immediately backed up after its creation. Instead, the information is backed up on the standby device after around 10 seconds after the creation. The types of sessions cannot be backed up in automatic mode, like the created sessions created by traffic destinated to the server. For example, the sessions created for administrator logins on that particular firewalls, those ones are not backed up. The half open TCP connections also cannot be backed up, and also the UDP fast packets, sessions created can also not be marked up because they're not matching subsequent packets, and this can be backed up in a quick session backup. And we're going to look at a quick session backup. So that is automatic. Now we have manual. Basically, maybe what we can pick out of automatic is that with automatic, it happens every after 10 seconds. Once you send the configuration, then the backup which can be backed up is backed up after 10 seconds. And these guys, sometimes some configuration commands are backed up immediately. And some of the data that cannot be backed up, like administrator login details for that particular firewall, cannot be backed up on other firewalls. So let us look at manual batch backup. When you hear the word manual, that means you have to do things manually. So manual needs to be triggered by the configuration of manual batch backup command. You go into your console and type in manual batch backup, and then you are able to start backing up the data. This backup starts immediately and applies to scenarios where manual backup is required when the configuration of two devices are asynchronous. And after the manual backup command is executed, the designated active device immediately synchronizes its configuration commands to the designated standby device. When you press the command and hit enter, immediately the configuration commands are executed, and also the manual batch command is executed. The designated active device immediately synchronizes its status information to the designated standby device with no need to wait for automatic backup. So we are going to synchronize the configuration command with this session, with this backup mode, and also we're going to synchronize our status immediately. We go ahead, press backup manual, and then it will go ahead and synchronize and backs up our data. We have another one which we are calling the quick session backup. If you configure it on your firewall or on your group, quick session backup applies when the forward and reverse paths are inconsistent on load balancing networks. Inconsistent forward and reverse paths may occur on load balancing networks because both devices are active and able to forward packets at the same time. So if information is not synchronized in a timely manner, the reverse packets may be discarded if they do not match any sessions, causing service interruption. So therefore, quick session backup is required by a firewall to back up the status information in real time. So we use this guy. We want to back up the sessions in real time. Real time because if we are using both of these guys in a network load balancing networks, these devices may be in position to send and receive packets concurrently or in real time, we need to make sure that our status information is synchronized accordingly. Okay, so for timely synchronization, this function synchronizes status information, but not configuration information. Like we said, only the status information, our session table, everything are synchronized, but not the configuration commands. The configuration commands are not synchronized, and the synchronization of configuration commands, you can either choose to use automatic configuration or you can choose to use backup. This one for quick sessions, and it used in networking or in environments that are doing maybe load balancing, and we want to make sure that we back up our session information in real time, but not the configuration commands. So after this quick session backup is enabled, the active firewall can synchronize all the status information, including those not supported by automatic session backup, to the standby firewall. Therefore, quick sessions can be synchronized to the standby firewall immediately when they are set up on the firewall. So then we have the last one, which we are calling the automatic synchronization of firewall configurations after restart. Automatic synchronization of firewall configurations after restart. Remember, you may have scenarios. Maybe you have updated or upgraded the firmware of your firewall, or it's misbehaving, and you decide to restart it. You decide to, pass on the restart command, and your firewall is restarting. As the process of restarting and maybe even upgrading, this firewall is not available. And if it was the active firewall, that means that it's no longer going to be the active. According to the guy, they're not going to receive 3 hello packets within the 3 seconds. go ahead. VGMP helps us to control and manage the switchover, and then the standby firewall in that group becomes now the active firewall. Please mute your microphone if your microphone is unmuted. So it become the active firewall. It has now become the active firewall, but now you may need to make a few configurations, change a few configurations here and there. In the time when this guy is away, you could maybe add a new user, you could maybe even add a new ACL, you could add a new role, maybe because of what you wanted to configure, or even some rules which can be automatically put in, like we shall see in the later chapters. Some new configurations are added onto your configuration command. And now this guy is done upgrading. After like 15 seconds, he's back up and he assumes the active state. Remember, we have new configuration, or you could even have deleted some rules that are no longer important in the time when he was away. So when he comes back now, because he's not up to date, he is not aware of some of the changes. So therefore, we have a mechanism to make sure that even these new rules which have been in his absentia can be synchronized, and now he can be at the same speed with the other firewalls within the network. So in the hot standby networking, if one firewall is restarted, the other firewall processes all the services during the restart. In this period, the firewall that processes the services may have configurations added, deleted, or even modified to ensure that the active and standby firewalls have the same configuration. After the firewall is restarted, their automatic configuration, all configurations are automatically synchronized from the firewall that has the processes. And only configurations can be backed up or synchronized as such as security policies and NAT policies. Configurations that cannot be backed up are like routing protocols like OSPF, and more so maybe the BGP protocol. These ones remain unchanged and they're not backed up, or they're not backed up on automatically after restart. So configuration synchronization can take up to 1 hour, subject to the amount of configurations that need to be backed up. And during the synchronization, you are not allowed to execute any commands that can be backed up between firewalls. Those are the two different kind of backing up scenarios. So let us look at the basic networking and configuration of a dual system hot standby. The basic networking of a dual host system standby. So in dual system hot standby networking, the firewalls usually work in routing mode, and the downstream switches are separately connected to the firewall through two links. In normal circumstances, firewall A here is firewall A functions as the active firewall, and if the uplink or downlink of firewall A goes down, then firewall B, which was a backup, will automatically become the active firewall, and then the switch traffic is transmitted through firewall B. When upstream and down service interfaces of a firewall work at layer 3 and connect to layer 2 devices, configure Hrp groups to the on service interfaces, so that Big Gmp Group can monitor the layer 3 service interfaces through Vrrp groups. How to configure this on command line? I'm not going to take a lot of time. Basically, when you open your firewall, I shared the ENSP file. After this class, I'm going to share a full, please mute your microphone. There's some working noise in the background. After you go ahead and open your ENSP, go to your firewall, you can go ahead and try and create some of these things. Set those things. After the active or standby parameter is specified, the Vrp group added to the active or standby group. Up to 255 Vrp groups can be configured on each common physical gigabit Ethernet interface. So you can go ahead and configure those things. Configuring the Hrp, we talked about the Hrp. What did we say the Hrp does? Who remembers? It backs up two things. Julius, your hand is up. Let me take on Julius. He has not contributed anything. Julius, your hand is up. Okay.
Mic check.
Go ahead.
It backs up the status data and the key configuration commands.
Yes, and key configuration commands. So this is how you can be able to configure it on our networks. So you go and say Hrp enable, Hrp standby configuration enable, then you go ahead and specify those things. Okay, will not take a lot of time on them. Configuring Vrp group configuration example on the command line. This is one example how you can configure those things. Enter your interface and say gigabit Ethernet 001, and you enter that interface. And after entering that interface, then you are in position to go ahead and add an IP address, specify the IP address for that interface, and then specify the ID number, and then also configure the virtual IP address for that group. Okay, and this will act as the default gateway for that entire group, much as you have different routers. So go ahead, open your router. After you open your router, go ahead and enter the interface 001, specify an IP address for that interface. Go ahead in that interface and specify the group, and then you also specify whether it's going to be in active mode. If you also want to configure Hrp group on USB, on firewall B, go ahead, do the same, give it an IP address, and go ahead assign it to this same group one, assign it a same virtual IP address. Please mute your microphones if you're not speaking to the class. The next time, I'm going to just remove you from the call. And then we put it in the state. For this time round, we have given it a state of standby. We have not given it active. We have put it in standby. Hrp configuration on firewall A, you go ahead and say Hrp enable, Hrp mirror session enable, then you go ahead and you specify the interface, and then this will be our heartbeat link. Okay, this will be our heartbeat link. This interface that will connect from one firewall to another will be our heartbeat link. So to view the status of an interface in a Vrp group, just go to display Vrrp interface, and then you select the interface which has your links, and it will give you the details, whether it's in active, standby, what those things. You should be able to see them later on. Viewing the Hrp status on the command line, also go display Hrp state, and then it will show you the state, that the current state of this firewall is active or standby, depending on what you would have configured, and the current virtual routers configured are as in the active state. We have this interface here, and also this interface, and they are in active group. How you can configure them on a web user interface? You can just go to system. After clicking on system, click on availability, high availability, then go on dual system hot standby. That thing will be there. You'll see it under system and high availability, and click on edit, and then you are able to add these different functionalities. I'm not going to go through a lot of these things. They are a bit straightforward. When you go through the material, you should make yourself more conversant. Basically, just look at the picture and say, okay, here we are enabling, we are disabling, we are checking here and there. Basically, that's how you'll be able to configure. If you can manage to run ENSP, I'd encourage you to go ahead and try it out and try playing with some of these other things on your firewall. So this takes us to our quiz for today. And we are saying that Hrp enables the active firewall to synchronize all configurations and information to the standby firewall. Therefore, the configurations and information are still available after a restart. As a result, no information needs to be configured on the standby firewall. True or false?
False.
Why is it false?
A standby firewall can also act as a master firewall after the master firewall has failed. So it needs to be with the same configuration as the master firewall.
Okay, thank you, Romeo. Anyone with a divergent view? Thank you, Romeo.
I check.
Go ahead, Watson.
Yes, I think just like my colleague has said, the last statements just negates the whole thing, where it says, as a result, no information needs to be configured on the standby firewall. Now imagine you need to add a new user, a new protocol. You can do that and it will just update the restarting device.
Very true. Just like these our colleagues have said, after a restart, during the time when our machine, which was the master, right, is restarting, it's unavailable. Its role is no longer going to be a master, isn't it? Its role is going to become standby, isn't it? And the one which was standby is now going to become our new master. And in this time, as this guy is away restarting, and maybe for power failure, which could even take you like 3 hours to troubleshoot as a network engineer, right? It could take you 5 minutes, it could even take you less, depending. But in the time it was away, maybe someone switched off the switch, you are pinging, you're unable to get it, you go into your rack, you find a beaten cable, you replace it. It could even take you 5 hours or 1 minute, depending on the problem, right? In this time, once it is away, your network is not interrupted because you're using dual system hot standby. You already have another firewall which assumed the master role. But in this time, you could either modify configurations, you could even delete configurations, or even add new configurations, right, on the master. So when this guy comes back, there is definitely need for information to be configured on this so that it's consistent with the current master, isn't it? There's definitely need because these configurations will have now to be synchronized. And that's why we looked at the fourth kind of backing up and we called it automatic synchronization of configuration after restart. I hope that is clear. So which of the following protocols is used to control the switchover of the Vrp groups in the firewall dual host standby networking? Which of the following protocols is used to control the switchover of all Hrp groups in the firewall dual system hot standby networking?
A.
GMP.
Yeah?
The
Yes,
answer
I
is
see.
A.
I was hearing someone says B. This guy is the management protocol that controls the switchovers with these guys, right? Within the Vrrp group. It controls and manages all the switchovers. So we have looked at the technical principles of dual system hot standby and the basic networking and configuration of dual system hot standby. And that brings us to the end of this chapter. And thank you all.